Active 4.2, we're going to be talking about how to find exponential equations given some points, which is called regression. So in Algebra 1, we found a linear equation given 2 points. So you'd find your difference in x, difference in y, and then you'd work back to find your b. So here. Now we need to find the a, which is our y-intercept, and our b, our base, to write an exponential equation, which is y equals a b dx. We still need to find both of our constants. So here we have in a table an exponential function of the form f of x equals a b to the x. Determine the values of a and b and explain your reasoning. All right, well, a is our y-intercept. So if we have x equals 0, we get a for free. So a is going to be 5. B is our ratio. It's the amount that our terms are increasing every time. So from 5 to 15, our ratio is going to be 15 over 5. It's going to be 3. From 15 to 45, we got 45 over 15. That ratio is also going to be 3. Here, we got 135 over 45. And that ratio is also going to be 3. So you can be pretty confident that every time our x increases, we're increasing by a multiple of 3. So because our ratio is 3 every time, our b is going to be 3. So you find the ratio between your terms, and that's going to be what your b is. So our final equation is going to be f of x equals a is going to be 5, and then b is going to be 3 dx. But you can plug in some points, like if we decided to plug in 2, then we have 5 times 3 squared, which is 5 times 9, which is going to be 45. And we're going to get this point. So it's always good to check your work, so to toss in a point into your equation to see that you get the right output. All right. So from the table is pretty straightforward. Where it gets a little more complicated is when we have just 2 points. So let's find the exponential function of the form f of x equals ab to the x again. And if it is known that f of 0 equals 8, and f of 3 is 1,000. Okay, that's a little trickier. Well, one upside is that they gave us the y-intercept again. Remember, the y-intercept is always our a. So if we have f of 0 equals 8, well, that's our y-intercept equals 8. So a equals 8. All right. Okay. We don't have a way to find b from 1 point. We need to compare 2 points and have a ratio, right? Okay. So so up here, we divided our f of x's by each other. Let's do that again. So we got f of 3 divided by f of 0. That'll give us a ratio. Okay. So we're going to plug in everything we know about f of 3. Well, a is 8. We don't know b, but we know that we plugged in for x and we got 3. So we have 8b to the power of 3, because 3 is our value for x for this one. So we have our a, our unknown b, and then we have, oh, I'm sorry, this is not correct. I'm just going to erase this and we're going to start over. Sorry about that. We're just going to work from our second point. So if we're going to plug in, because we don't have to do the whole ratio thing, we can find f of 3 equals 1,000. We don't have to do a ratio yet. That's for a later question. Sorry about that. So we're going to plug in everything we know about f of 3. So we have a, b to the x equals 1,000. Well, we know x is 3, and we know a is 8. So I'm going to plug those in. So I get 8b to the 3 equals 1,000. It's much simpler. Okay, so solving for b, I'm going to divide both sides by 8. I get b cubed equals 125. And you can use your calculators, or maybe you know some powers. And you can see that if you take the cube root of both sides, cube root here, cube root here, we can say that b equals 5. So now we have our a, we have our b, and we can write our equation f of x equals 8 times 5 dx. So we're given our y-intercept because they gave us our value at 0. So that gives us our a. And then we can plug into our other point. Since our only unknown is b, we can just solve for b. Okay. Now we're going to have to do a little bit more work. So once you're done with exercise 2, let's move on down to exercise 3. All right, an exponential function exists such that f of 4 is 3 and f of 6 is 48. Which of the following must be the value of the base? You can use your calculator. All right. So to find the value of the base, we do want to use the ratio. And because we're not, the key difference between 3 and 2 that got me confused earlier is we're not given the y-intercept. We're not given f of 0. So we're going to have to do some more work. So we know that f of 4, we can try to plug in, f of 4 equals ab to the 4th. We know f of 6 equals ab to the 6th. But now we have 2 variables, and we can't just cancel one of them out. Unless we divide. So we know that f of 4 is 3. We know that f of 6 is 48. So what happens if we divide f of 6 over f of 4? All right, well, we have ab to the 6th equals 48 on the top. And on the bottom, we have ab to the 4th equals 3. Okay. Well, the ratio that gives us is, second page, well, our a's cancel now because they show up on the top and on the bottom. So we just have b to the 6th over b to the 4th equals 48 over 3 is going to be 16. You can check that with your calculators. Okay. Well, now our rules of exponents tell us that because we're dividing things with the same base, they both have b as their base, we can do b to the 6 minus 4 equals 16. That means that b squared, because 6 minus 4 is 2, is 16. And if we square root both sides, we get that b equals 4. So our base has to be 4. Let's go back up and see if we have that option. We do. B is 4. So here, because we weren't given a, we had to divide our two terms by each other so we could cancel a out. And then that left was just b and the ratio over whatever our numbers were, which we could then solve for b by using our rules of exponents and then some careful square roots. Once you got a grasp on that, let's move on to exercise 4. Okay. An exponential function of the same form, y equals a times b to the x, passes through the points 2, 36, and 5, 121.5. Eek. All right. So we're going to have to, I guess the hidden question here is going to be find the equation. Looks like a misprint. Didn't make it through your books. All right. I want to start by doing the same thing we did last time. So we know f of 2 equals a b to the 2 equals 36. And we know that f of 5 equals a b to the 5th equals 121.5. So if we take our ratio, our a's cancel, our b's will subtract. So we get b to the 5 minus 2, which is, of course, b cubed equals 121.5 over 36. All right, so if we do that division, we get this equals 3.375. I just did this on my calculator. 375. All right, so now we have, I'm going to move up so I have a little more room. So b cubed equals 3.375. If I take the cube root of both sides, again, using my calculator because I'm not psychic, we get b equals 1.5. Almost there. So almost like we solved systems, now we can plug this back into one of our other points. So I'm going to separate this off. Because we know that f of 2 is 36. So if we plug in b equals 1.5, we can get f of 2 equals a times b is 1.5 squared equals 36. So 1.5 squared is going to be 2.25. So we have a times 2.25 equals 36. And then we're going to get that a when we do our division out, so divide by 2.25, divide by 2.25, we get a equals 16. And that's both the variables. Now we have our a, we have our b, and we can put it all together down in purple over here. We're going to get f of x equals, our a is 16, and we have our b is 1.5 to the power of x. A little tricky. Our numbers aren't quite as clean as they often are. We can handle it. We can do it. Our calculators are very powerful tools as long as you know how to use them properly. All right, once you're done with this, let's move on down to exercise 5. All right, so now we're going to find it from a graph. So be careful in terms of exponent manipulation. So find the equation of the exponential function shown graph below. Be careful in terms of your exponent manipulation. State your final answer in the form y equals a times b to the x. All right, so this is actually not so bad because we can see just 2 points, same as we had last time. So I can tell you f of, let's write this in another order actually. Let's do f of 2 on top. F of 2 equals 1/2 equals a b to the 2. And we can do f of -2 equals 128 equals ab the -2. So if we do out our ratios, our a's will cancel, just like always. Okay, so let's be careful with this. So 1 half divided by 128 is going to be 1 over 2 times 128. Remember how we do our fractions. And then we have b squared on the top minus our exponent on the bottom. Minus a minus, it's going to be a plus, so we actually have plus 2. If you need to review how your rules of fractions or rules of exponents, please do and come back in a minute. Otherwise, we're going to move ahead. 2 plus 2 is, of course, 4. So we have b to the 4th. So we can solve 1 over 256 equals b to the power of 4. And then we're going to have to take our 4th root with our calculators. So index of 4, index of 4. And we're going to get b equals 1 over 4, which makes sense. It should be less than 1 because here we have a decay curve. We're headed down, we're decreasing. So it makes sense that our thing should be less than 1. All right, so I'm going to box that off. And like we did in systems, like we did in the last problem, we're going to plug this into our other thing. So I know that when I have f of 2 equals a times b is going to be 1 half squared, I get 1 half. So I can tell you that 1/4 a equals 1 half, multiply across, and I get a equals 2. Box it off as well. And now I can label, which is such an important step whenever we graph. This person did not label very carefully, so we had to do their work for them. We can get f of x equals 2 times 1/4 dx. I believe this is our last exercise. Yep, it is. Our last exercise, we're going to talk about an application, bacteria. Often living things will grow at exponential rates, which is why bacteria are sometimes so dangerous, because exponents grow very, very quickly. So we know that after 4 hours, all right, time equals 4, the population is 98. And after 9 hours, do a different color because it's a different point. 9 hours, it's 189 bacteria. Determine an equation in y equals a to b to the x form that models the population y as a function of the number of hours x. At what percent rate, another color, is the population growing per hour? All right, I'm going to extend my page because it's going to take a little bit. All right, big. All right, so I'm going to write this in the same form we've been doing. So I'm going to have f of 4, because my time is 4 for my red point, equals 98. 98. And I want, for my green point, f of 9 after 9 hours, 189. Okay. Then I'm going to fill in what the rest of my equation looks like. It's going to be a b to the 4th. This one's going to be a b to the 9th. All right. All right. So I'm going to do my division. So I'm going to do f9 over f of 4. Try to keep switching the up and down order, but I think this one's going to work out better for us. So you do ab to the 9th over ab to the 4th. A's cancel. This is going to equal 189 over 98. All right, so we're going to get, if we go down one, we're going to get b to the 9 minus 4. It's going to be b to the 5th equals 189 over 98 is equal to One second, I got with my calculator. About 1.93. We can round a little bit. We don't have to give the exact answer every time. All right. Just try to keep like 2 or 3 decimal places and then round. All right, so we're gonna take our fifth roots to get our b. Fifth root, fifth root. And I'm gonna calculate. Our b is 1.14. Now we're working with some real gritty numbers, right? Nothing like the 2s and 1/2. Okay. So now that we have our b, same as we've done for the last 3 problems, we're gonna plug back into one of our points. And let's do the red one. So we got f of 4 equals a, well, b is 1.14 to the fourth. That's 98. All right, well, 1.14 to the fourth is 1.69. A is 1.69 equals 98. So we divide across. We get A equals 58.02, which I'm going to round to 58 exactly, because we have to have an integer number of bacteria. You can't have 58.02 bacteria to start with, because remember A is our y-intercept. It's how many bacteria we start with, so it should be a whole number, or it doesn't make sense. Okay, so we start with 58. So the equation we write is going to be f of x equals 58 times 1.14, that's our b, to the power of x. And the last question is this purple bit. What percent rate is the population growing per hour? We haven't talked too much about percent rate so far, but this is the amount that we're growing. Because if it was a rate of 1, if b was 1, we wouldn't be growing at all. So if every hour we're growing 14 hundredths of our population is increasing, well, 14 over 100 per, this means divided by, and 1 cent means 100, like 1 cent is 100th of a dollar. So 14 over 100 is going to be 14% per hour. So if you've been instructed to do the independent practice, now would be the time. And if not, until we see you again, make good choices.